Um, so we'll build on the few examples that we have seen yesterday. So we have done it with the help of object class and runtime polymorphism. Today we'll see how we can use the concept of generics there, which the team NumJava was talking about. So here is another program in front of you. So instead of making our own classes, I'm using some predefined classes here, basically string and a few wrapper classes. So we have three objects here, not three, two objects here, one primitive data type. And we are calling print function on this. We have just one version of the print function. So it's using runtime polymorphism here, taking object reference and printing the value here. Okay. So I hope it is clear to you. So what do you think is this double D? Is it an object or a primitive data type? In line 3. So if you look at lines 5, 6, and 7, how many objects are there? Are there 3 objects? 1, 2, or 0? One object, which is that? String. This integer, it's not an object. So what is the difference between line number 6 and line number 7? Is there any difference or are they the same? Right, line 6 is a primitive integer. That's not an object. If you look at line 7, that's a class integer, right? So you're making an object of a wrapper class integer here. What's happening here is autoboxing. It takes 1, 2, 3, converts it into an object. If you want, you can also write it like this. These are not exactly the same things, both of them, but pretty much same. So what you are doing here is creating an object of type integer. Okay, what about line 7? Primitive or object? That's a primitive double data, right? So these two are objects in lines 5 and 6. Line 7 is a primitive data type. Then we are able to call this print function on all of these. I hope this we clarified yesterday. So this thing, when you call print S is passed to obj here. So this is string and object is a superclass of every class, right? So you can pass a string object to an object reference. Same holds for integer. Now, if you talk about double here, here is the catch again. Double is a primitive data type, but your parameter here is a class type or it expects an object. So in this case, what will happen when you pass this argument to the parameter? I hope you understand arguments and parameters, the differences. So if you say print S, so this S over here is an argument and obj is a parameter. I is an argument, obj is a parameter. So similarly, D here is an argument, obj is a parameter. So what happens? When you copy D to obj, it will convert it into an object. So auto boxing is happening here. And then you are able to see all the values. So let's quickly run it and see. So this works fine. You see all the 3 values, everything works perfect. Now let's make a small change to this code. And what I'll do is I'll say, okay, you show, note the value, the int value, whatever you are passing here. People who are coming now, please don't talk. So instead of directly printing obj here, I'm going to use a function called int value. Okay, can you tell me about what this function does? Gives integer value of what? The object. Okay, and what do you think? Is it function defined for strings, integers, doubles, all the classes? Can you quickly check your Java documentation and tell me? We can just Google for int value documentation of Java and tell me what does this function do? And for which all classes can you use this function? converts a number to int value. Yeah, so Google says it converts a number to int value. So the question is what number means here? It's number to Janus term. So what kind of number? String? Is string a number? Short? Short, long? Are all the primitives counted in here? So how many primitives you have? Short, long, byte, double. What about character? Boolean? Which all of them count this number? Right, so you'll find this function int value in not in all of your wrapper classes, but in 6 of them. So you can go to the integer class documentation, there you will find it. You can even go to the documentation of your double class. So let me just quickly show you. This is the class double, and let's see if it has the function in it. So it's int value, right? It's not integer class, it's double class. It's not a static function. That means you can call it through an object of your double type. So let's say the object is D. You can say D dot int value and it will return the value of this double as an integer. So you'll find the same function even for your byte, short, long, but not for all of your wrapper classes. Just a second. So you see here, so the number we talked about, we said that you can use this function for all the numbers. So what does number mean here? So if you look at class double, it extends another class, which is the number class. So you can click on number class and you can see which all classes are extending it, which all are the subclasses. So you'll not see all the wrapper classes here. We have got byte, double, float, integer, long and short. Right, so for all those classes, you have this function called int value. So let me show you this function. So at the number class, this function int value is an abstract function. What does that mean? It doesn't provide you the definition. So whatever other classes are extending this number class, they will provide their own implementation of your int value function. But the point is this function is not there for all the classes. It's only there for number classes. So I'll quickly show you one more thing. So this is how the hierarchy of your wrapper classes look like. Right, so this is what is happening. This is your number class. All your byte, short, integer, long, float, double. Since wrapper classes are extending it, Boolean and character are not extending it. They are directly extending your objects. So now if we come back to our code, do you think it will work? Or is something wrong there? So for every each of these three arguments, you are calling this function print and you are trying to look at their value, int value. So you see, we convert my integer to int, it probably remains the same. Convert double to int, so it will truncate the part after decimal. But what to do about string? There's a problem, right? I'll say, okay, I'll give you a string called hierarchy, convert it to an integer. What will you do? What does that even mean? That doesn't mean anything, right? It cannot magically do things. Right? So if we run this now, so you see an error here. So this error is slightly different. So it says I cannot find this symbol int value. So we have seen something like this previously also. Why does it say that? Because you are converting all your strings integer and double to object, right? And here you are invoking the int value function for the object class. Do you have that function for object class? Right, we discussed this in runtime polymorphism. If you call a function right? From a superclass reference, that function should be there in the superclass. But this int value function, it's not there in the object class. It's only there for integers and doubles. So what do we do now? Upcast or downcast? Oh, sorry, downcast. Right? So we have upcasted here. So we are saying you upcast a string, integer, and double to object. What you now need to do is a downcast. To integer. Right. So now this is a good question. So what do we downcast it to? Integer? Right. Right. So you can downcast it to a number. So for any kind of number, it will work. So we'll come here and let's try to downcast it. So we'll say don't do it on OBJ. You first downcast it to a number and then do it. What do you think about this code now? Will it work? Magically? That string part is again there. Right? But let's see what happens. We don't get any compilation error. So compilation actually already compilation, there is nothing wrong with this code. I checked match work with data types, everything works fine. You can pass the arguments to object data type. So anyways, whenever you are using this function, you are downcasting it to numbers, so it should work. So at the 11th compiler, everything is all right. But let's run this code. When you run this code, you get a class cast exception, right? As expected. And that is for your string part. Because how do you downcast a string to a number? You cannot do that. String is not extending number. So you get a runtime error. So to show you that, you can actually take this line below. So your code will work for lines 10 and 11, but it will give you an error for line 12. Right, so it shows you the int value for your integer, int value for your double. The moment you come to string, it gives you an error. Right? And it gives you a runtime error. And as we discussed, that is something we do not want. It means that when you developed your product, everything was all right. Now you have given it out to the client and something happens when he's trying to run it. So we want to catch every error at the compile time. We do not want problems at runtime. So how do we resolve this? So for that, we have one more concept of generics, and that is quite similar to what we are doing here. So the thing here is what we are doing is upcasting and downcasting. So apart from giving us a runtime error, it also has performance issues. So whenever you have an object, you upcast it, change its style, and then you downcast it. So there are a lot of other things happening in between. So it also reduces the speed of your code. So we'll look at something now which is more safer and more faster also. That's the use of generics. So what we are saying is we don't want an object reference here. It's just that whatever is the type that's going to be passed here, I don't know what the type is going to be. It can be an integer, it can be a double, it can be anything. I just don't know about it. So you see, it is same as this thing here. When you call this function, right, we write object obj. So the obj, which is the parameter here, we are just implying we don't know what obj is. You'll come to know what obj is when we call this function. So if you say print I, obj will become I. If you say print d, obj will become d. If you say print s, obj will become s. So that's what's called a parameter, which can take different values. So what you want now is you want to treat your type also as a parameter. I want to say just like obj, I do not know what its type is going to be. It can be any type. And I'm not saying that it will be object type or a super class. It's just that I don't know what the type is. So just like you have used a random name obj here, you can name a random name here. You can even use your name. But if you look at the Java terminology, they use the word T. T stands for type. So this one is called a type parameter here. So we are saying I do not know what T is going to be. You just infer it. Based on what argument you are passing to it, a little bit of syntax. So you need to indicate T here in this diamond basis. So that makes it a generic function or a generic method That means we have a parameter also in addition to the other parameter which is obj. It's going to have a type parameter t, and you can actually deduce it from here. Whatever is I, t or s. So if you are calling print I, t will become int. If you are calling print d, t will become double. And if you are calling print s, t will become string. And as Nagesh she specified yesterday, P can only be a class, right? It cannot be a primitive data type. So anyhow, auto boxing is happening here, it will be a class. So that's all about generics. If you understand this example, we'll just work through a few more examples and that's all. So that's all. We have just replaced that object reference with the T and we have specified a T here. Let's see. Okay, so again the point is at compile time you don't see any error. Runtime you still see an error for string. And that is what we want to get rid of. So you do not want an error at the runtime. You don't want to do any upcasting or downcasting. So what you do is here you can make it a bounded time. So right now it means T can be anything. T can be any class. You don't want it to be any class. You want it to be any class that extends number. So you are saying that you are bounding this type. It cannot just be any type. Any subclass of number will work here. Other than that, if you try to pass anything to this function, it will give you a compile time max. So that's how generics provide you type safety. If you try to run this, if you try to compile this code now, it gives you an error right at the compile time. It says that in one line you are calling print s, but your type that is required is upper bounded by number. You cannot pass it a string. That's mostly what's there in generics. So that's how you can write a generic function. Let's look at a few more examples to make it clear. Let's say simpler examples. So something which we were working with yesterday. The bounded type. So bounded type only means, so if you only write t here, it means that whenever you are invoking this function, it will accept any type, any type, any kind of object, right? But the point is, if you look at this function void print, since you are using the int value function here, it should accept only those types which are number types and not other types. So you can put that constraint here. You can not pass in any type. You can only pass those types which extends number. If you try to pass some other types, it will not work. Right, so as an example, assume that you had some function called fly here, right? And inside you were calling the fly method for certain objects. Now the point is not every object can fly. So in that case, you can write something like t extends flyable. That will mean it can be any type, but only those types which are implementing flyable interface or which are extending a flyable class. So you can limit what types these functions can accept. Yeah, you can say it makes it flexible. And that too, you are resolving it at the compile time itself. So we are not doing any runtime business here. So yeah, so this was our print example code which we were working yesterday, a whole lot of classes. And we have done it with the object class yesterday. So we said that whenever you want to print any object, you make it object class. So how do you convert it into a generic function? It is straightforward here again. Same way as we did now. Right, so we don't want an object class here. We'll say it's a generic class. T, it can be any class. And you just place a T here. That's all. And this code will work in the same way as it was working yesterday. Do you need some time to look at this? I can give you the file and you can inspect it for a while if you want. How many of you want to do that? Raise your hands. Otherwise, I'll continue. Oh. So yeah, this was one. . This was yet another. So you can again do the same thing here. You are calling this print method for different kind of objects over here. I'll comment this line because this one will give you an error. We're trying to get a class for the primitive. So this we just included yesterday to show you. Uh, yeah, so print all these values. So again, instead of object, you can just replace it by a type parameter and you include your type parameter. Okay, so one more thing about this. So coming back to the same code over here. So let's say I want a different function. So you can have more than one type parameter. What I mean by that, let's say instead of this, I want a function called print pair. And I'm going to pass two things to this function. So maybe I'll pass, let's say, as and I. So if I pass s and I here, it means that first it will be printing a string and then it will be printing an integer. So if you look at the parameters for this function, the first one should be a string and second one should be an integer. But similarly, I can also print something like, let's say, print pair d comma I. In that case, it should be a different overloaded function where the first type is a double and the second type is an integer. So can you tell me how many versions of print pair will be there? How many types of print pair are possible? In how many ways can you print pairs? We have three types here, string, integers and double. 9, right? So it can be, you might be printing a string or a string and an integer and then maybe a string and a double, maybe a double and then a string. So there are really 9 options. We don't want to write 9 functions. We write one function which will work with all types, right? So the point is, if you look at this print pair function, there are two types, type 1 and type 2, which we need to work with. So how can you write a generic function for this? Just a second. So you can go with public static. So you can say my first, so you can literally use anything other than T also. So you can say I'm using two typed parameters, U and V. It can either be your names, you can use, so generally they use capital letters. So parameterized function with two type parameters, U and V. And the name of the function is print pair. And what do you do next? What should I write? I have two things to print. So let's say show me value 1 and value 2, or let's say my first first value that I want to print is x, second is y. So basically s will be copied to x and I will be copied to y. But I really don't know about what their types are going to be. So you can just write ux and vy. What does that mean? I don't know what u and v are, but u is one type and v is some other type. U is the type of x, v is the type of y. It can be any type. And you can just go ahead and print x plus, let's say, comma plus y. That's all. So you don't need to write 9 functions here, just one will suffice. Let me just check if it is working. So right now I am printing two pairs, string integer and let's say integer and double. And I should comment this because this was giving us an error. Right? So it shows you a string followed by an integer and an integer followed by double. So you can actually have as many type parameters as you want. So we are using 2 here. Any doubts about this? I'll give you 5 minutes so that it sinks in. And then we'll look at some more examples. So in the reference number, what I'm saying is that you are solving this function. So each function is going over the time of the open, then you pass to this function. If you don't write anything here, that means you don't pass any of these. If you write the reference number, then you have those types to this function which extends number. So it will just reject. You cannot pass string to this function. So number of each that string. So the point is right now it will not even compile. That would give you an error if you were in the object class, right? If the compiler itself will check that the moment you call print doesn't extend number. If it's in the compiler itself, that you cannot close it. So you have to remove that statement. It is possible if you design the functions. And also, you can use the previous function. You can even use your name there. It can be anything, A, B, C, D, and even reuse. Because there are two types. You can also use T commands. So T command we had. So that, but you're correct. You can use that to convert a string to a number. So that's what she was asking. Right? Is there a way to convert a string to a number? You can implement a library with that and then you can make this course. Time that so you won't get to randomize issue. The moment you try to do something like compile and map, that you can do qualification for us together. So this makes your time that has sense. So using the case of if you were using object class, it's very much possible. You might see any error, but when you run it, you run it. Okay, so we'll see one more example. Okay, so here is a class called array printer. So there are three classes: cat, dog, car, empty classes, and then you have a function called array printer. I think this was something we didn't discuss yesterday, right? So you have so what you're trying to print now, instead of printing an object, you are trying to print an array of objects. So you have a print function for cat array, a print function for dog array, a print function for a car array, for integer array, for double array. There are 5 functions. I should actually, yeah. And this is your main, wherein you make arrays for your cats, dogs, cars, integers, and doubles. My bad, I just changed this code. And what you are doing here is, okay, let me just remove this. Right. So what we want now is a single function, a single print function which will work for all kinds of arrays. Right. We don't want these multiple functions. So how do we do it with generics? So we have to be a little bit careful here. So I'm going to change a few things here. So I'll just take one of these and convert it into generic. So the best way to write a generic function is you write it for one type and then you see where you can fit in generics. So it's already written for the cat class, but we don't want it for the cat class. We want it in general to work for every array of objects. So I'll just change this name. This is just a parameter named cats, right? So I can give anything here. So let me rather call ARR. So ARR indicates it's an array. So what else should I change? So this also becomes an ARR. And instead of the word cat, I'm using the variable each. Just like your for each loop in Python. But as of now, I have just changed the variable names, done nothing else. So we are saying you are getting an array of cats. Go through every cat in this array and print it. Right now, you don't want to do it for cats, you wanted to do it for any kind of object. So, what do? You can again take a type parameter T Instead of that, what do? Write T here, right? So you are saying I have a type parameter and this array type that I'm passing you can be any array type. Do you think anything else I should change in this function? In this function here? So look at this. This is also a type, right? So if you are printing an array of cats, it will be cat. If you are printing an array of dogs, it will be a dog. If it's an array of integers, it will be an integer. But you don't want it to be a cat or a dog or an integer, it can be anything. So you should write T here also. Right? So whatever type you are passing in, that will come here and here. So it basically acts like a placeholder. Okay, so I'll stop here. We'll look at a few more examples of generics in our next class. So right now we have a presentation by the group Milana who will quickly show you how to achieve your database integration in your projects. So for those of you who are struggling with it.